Today we're going to talk about mole conversions using the chemical equation. We spoke previously about how to balance our chemical equations. So now that we know how to balance chemical equations, we can go further and we can figure out how to convert one product into another product or a reactant into a product. So let me ask you this question. How would you read this equation? Give it a minute and try and just say it out loud. So practice naming compounds correctly and practice using the terms reactants and products. I hope you came up with something that sounded like this. 1 mole of calcium hydroxide reacts with 2 moles of nitric acid to produce 1 mole of calcium nitrate and 2 moles of water. So whenever you read that equation, what are you talking about? You're talking about what is reacting and what's producing. This is a big question in industry. So whenever you've got all of your reactants mixed together in a giant vat somewhere, with industry, they want to know what they're producing and they want to know how much they should be producing. So that idea is a theoretical yield. If your theoretical yield says you should make 500 grams of a substance and you only make like 300, then maybe the CEOs of the company are going to go yell at you, the lowly chemist, and say, hey, what happened? Why are we not making as much as we should? So figuring out how to read this equation and how to figure out how to answer the CEO's question of, oh, you messed up your math. Let me explain to you why I should have only gotten the 200 grams I did. Questions like that can be answered by doing molar conversions utilizing the chemical equation. Notice that whenever I say 1 mole of calcium hydroxide reacts with 2 moles of nitric acid, I could have also said 1 molecule of calcium hydroxide reacts with 2 molecules of nitric acid to produce 1 molecule of calcium nitrate and 1 molecule of water. They can use pretty interchangeably. But can you use the word grams? Can you say 1 gram of calcium hydroxide reacts with 2 grams of nitric acid to produce 1 gram of calcium nitrate and 2 grams of water? I hope you said no. The answer to that is absolutely not. Never. You can use the word molecule and you can use the word moles, but you cannot use the word grams. It does not work like that. Sometimes 5 grams of substance is actually smaller than 10 grams, but sometimes it's actually larger than 10 grams of a substance. That all depends on the chemical makeup of the compound that you're discussing. And so can you use the word grams to compare something? Can you say 2 grams of this should produce 2 grams of water? No. Never, never, never. So whenever you're reading this equation, make sure you know that those ratios that we're looking at here, this 1, this 2, this 1, this 2, those are all referring to either moles or molecules. You cannot ever say 1 gram of calcium hydroxide always produces 2 grams of water based on this equation. It is never right. So what is right? Let's practice with this. If I ask you the question, let's say you have 1 mole of calcium hydroxide and you have excess nitric acid, which means you have as much nitric acid as you need in order for calcium hydroxide to completely react. So whenever you see the term excess, just means you can just throw in a bunch extra, and as long as you're only interested in how much calcium hydroxide is produced, it's going to be available. So if you've got 1 mole of calcium hydroxide reacting, you need to have 2 moles of nitric acid. So this question assumes that there's at least 2 moles of nitric acid in your solution. So if you have 1 mole of calcium hydroxide, if you have 1 mole of it, how many moles of calcium nitrate are being produced? So this is kind of the simplest part of the question. If you have 1 mole here, how many is going to be produced? 1 mole of your calcium nitrate. If you have 1 mole of calcium hydroxide and excess nitric acid, how many moles of water are produced? So you notice here 1 mole, so therefore 2 moles of water are produced. this is always the case. If you have 1 mole of calcium hydroxide, you will always have 1 mole of calcium nitrate produced, as long as you have 100% yield. Okay, but we'll talk about that later. If you're asked the question, how many moles of water are produced, you're always producing 2. So then let's do the other flip side of this. If you have 2 moles of nitric acid and excess calcium hydroxide, how much of each of the products can you make? So if you have 2 moles of nitric acid, you can make 1 mole, once again, of calcium nitrate, and you can make 2 moles of water. This is the information that you should be able to pull from the chemical equation. So practice that. Go back and forth. We're talking about moles here. Let's go a little bit more difficulty level then. Let's say you have 8 moles of calcium hydroxide and excess nitric acid. How many moles of calcium nitrate then would be produced? So we're starting out here with 8 moles of calcium hydroxide, and we're interested in the number of moles of calcium nitrate, and we're interested in the number of moles of water. So notice, we don't start out with 1 mole here in the equation. So what we need to do is we need to utilize a new type of conversion factor. A conversion factor that relies on our coefficients of our balanced chemical equation to ascertain a response, an answer, to figure out how many moles theoretically of product you have based on a given amount of reactant. So the way I like to work these problems is for part A, so we'll label that A, this B. So for part A, what I've got is 8 moles of calcium hydroxide. You can utilize the coefficients in the chemical equation as a conversion factor. So what I mean by that is we've got moles of calcium hydroxide on the top. So we can put that in the bottom. What number goes here in front of our moles of calcium hydroxide? The number that is in our balanced chemical equation. So we have 1 mole of calcium hydroxide. The thing we're trying to get to in part A is how many moles of calcium nitrate. So to figure this out, we have to do the same thing. The number that goes here is our coefficient from our balanced chemical equation. So what this is saying is that for every 1 mole of calcium hydroxide that reacts completely, you're going to produce 1 mole of calcium nitrate. So in doing the math, 8 times 1 divided by 1, that means that for every 8 moles of calcium hydroxide, you're going to produce 8 moles of calcium nitrate. You may be saying at this point in time, well, that's easy. Why do I have to set up your stupid conversion factor? Please don't say that. Not because it hurts my feelings, because, you know, we won't worry about those, but because this is going to get a lot more tricky. So practice setting up these conversion factors, and whenever the problems get a lot more complex, you will have this new conversion factor, utilizing it very well to make it so that you're not making problems and mistakes in the bigger, more complex problems. So let's do number B for practice. Letter B for practice. Letter B says you're starting out with 8 moles of calcium hydroxide. So because I'm trying to get from moles of one substance to moles of another, that's what tells me that I use the coefficients. So moles of one substance to moles of another, you got to use the balanced chemical equation. So once again, I pull the coefficients out of our equation. So I've got 1 mole of calcium hydroxide is equal to, and this time we're trying to get water. So for water, I've got 2 moles of water produced for every 1 mole of calcium hydroxide. So in the end, I'm producing 8 moles of calcium nitrate but I'm producing 16 moles of water. So once again, these conversion factors all come from our balanced chemical equation. If it's not balanced, you will not get that conversion factor correct. Let's do some more examples. We're just going to do a lot of examples all in a row today. This next question says, if you have 1 mole of nitric acid and excess calcium hydroxide, how many moles of each of the products are formed? I want you to pause the video right now and practice this. Do this part on your own. So tell me how many moles of each of the products are produced. Pause the video and then listen to the explanation. Okay, let's discuss this. So for A, we're starting out with 1 mole of nitric acid, and we're converting it to the number of moles of calcium nitrate. So what that tells us is our moles of nitric acid goes on the bottom, and our moles of calcium nitrate are on top. So what number goes here? 1 goes here, and nitrate, 2 goes here. So 1, 2. So now we do our multiplication across, and we end up with 0.5 moles of calcium nitrate. Note here that it is definitely possible to have small fractions of moles. You can have half a mole, you can have 0.00079 moles. Because think about it. If you have a half a mole, you still have 3.011 times 10 to the 23rd molecules. You still have a lot of sample. So don't get freaked out by small moles. It's perfectly fine. Let's do part B now. 1 mole of nitric acid times, we're trying to get to water now, so 2 moles of water for every 2 moles of HNO3. So we do our math and we end up with 1 mole of water. So once again, these were the same types of responses where we're able to convert from moles of one substance to moles of another substance using the balanced chemical equation. Let's make it a little bit harder. Let's have some fun. If you have 1 gram of calcium hydroxide and excess nitric acid, then how many moles of each product are produced? All right, let's give this a try. Let's see what we remember from our last lecture. So part A, it says if you have 1 gram of calcium hydroxide, we need to get that to number of moles of calcium nitrate. So what do? Can we jump immediately to our balanced chemical equation? No, because we cannot convert grams of one substance to grams of another substance directly. We always have to go to moles first. So in order to go to moles first, that means we have to figure out how to go from grams of calcium hydroxide to moles of calcium hydroxide. Does anybody remember how to do that? I hope you remember that in order to do that, we need to look at our molecular weight. Because molecular weight is what allows us to convert between grams and moles. So what I want you to do is first figure out how many moles are needed in order to figure this out. So first off, we're going to do the calculation for each one of the molecular weights. So pause the video right now and figure out the molecular weight of all of these compounds. All right, so let's calculate this. Calcium hydroxide. So first off, we have to start out with the molecular weight of calcium. We have 40.078, and we have one of them. So let's multiply that times 1. Now you don't have to write the times 1 if you don't want to. Plus 2, because there's now 2 oxygens, times 15.999. And notice my units on all of these, I'm being lazy and I'm leaving them out. But note that my units for every single molecular weight are grams per mole. Grams per mole. So my second 2 that I just wrote there is because I have 2 hydrogens, and the molecular weight of hydrogen is 1.0079. So I'm going to go ahead and label these. Molecular weight of calcium, molecular weight of oxygen, and molecular weight of hydrogen. And then the 1 is the number of atoms. Number 2 is the number of atoms, and this number 2 is the number of atoms. So if we type all of this into our calculator, what we should end up for the molecular weight of calcium hydroxide, we end up with 74.092 grams per mole. Type that in your calculator and make sure you got it. Now let's do nitric acid. We've got 1 times 1.0079 plus 1 times 14.007 plus 3 times 15.999, because oxygen has a molecular weight of 15.999 and there are 3 of them. So that gives us a total molecular weight of 62.115 grams per mole. So that's our molecular weight for our nitric acid. Let's do calcium nitrate now. 1 times 40.078 plus 2 times 14.007 plus 6 times 15.999 equals 164.086 grams per mole. And let's do the last one now. Water. 2 times 1.0079 plus 1 times 15.999 equals 18.015 grams per mole. So those are our molecular weights for all of them. You remember, you get all of them just from this periodic table here by adding up all of the molecular weights. So let's go back to this calculation here now. So remember, we're pulling these molecular weights from the weights that we just calculated. So for our calcium hydroxide, we knew there was 74.092 grams of calcium hydroxide per every 1 mole. Notice, for your molecular weight, it is always, always, always a 1 that goes with your mole. Your number never goes with the mole, and it's never different than 1. So don't let the fact that our molar ratios for our balanced chemical equation, the fact that they change, don't let that confuse you from what you knew previously, that molecular weights is the number of grams per 1 mole. Let's keep going. So we converted from grams to moles. Are we done there yet? Not quite. The question asks us to figure out how many moles of calcium nitrate. So we have an answer right now in the number of moles of calcium hydroxide. So we can then convert from moles of calcium hydroxide 2 moles of calcium nitrate. I've got my calcium. So now we can type this all into our calculator and figure out what we get. So if you got 1 divided by 74.092, that means that we should have a total of 0.0135 moles of calcium nitrate. So how many moles are produced? That is our answer for A. Let's do B. We start out with 1.00 grams of calcium hydroxide. It's the same steps here because it has the same molecular weight. Our molecular weight of calcium hydroxide did not change. All right, but what does change is we're now converting from calcium hydroxide. So we got 1 mole of calcium hydroxide on the bottom. Now, instead of it being 1 mole of calcium nitrate on top, we now have 2 moles of water on top. So we multiply our last answer basically by 2, and we end up with a total of 0.0270 moles, and I rounded that, of water. So here, the main things to pay attention to is our first parentheses, our first conversion factor is our molecular weight. The second conversion factor is from our balanced chemical equation. All right, let's go to the next problem. The next problem is saying if you have 5.85 grams of nitric acid and excess calcium hydroxide, then how many moles of each of your product are produced? This is pretty much the same thing as our last example, except for this time we're starting out with nitric acid and we're ending up with each of the 2 products the same way. So what I want you to do is I want you to pause the video at this moment and convert 5.85 grams of nitric acid into calcium nitrate and then convert it into moles of water. So do both of those. Let's convert them. So A, B, A. We have 5.85 grams of HNO3 for every 62.115 grams of HNO3. You have 1 mole of HNO3. For every 1 mole, every 2 moles of HNO3, you have 1 mole of calcium nitrate. So our molecular weight was here. Our balanced reaction, our balanced chemical equation, gives us our numbers for 1 and for 2. 1, 1. So let's type this into our calculator and see what we get. 5.85 divided by 62.115 divided by 2 gives us 0.0471 moles of calcium nitrate. So that's part A. Part B is the same way. We have 5.85 grams of HNO3, and we're, instead of trying to get to calcium nitrate, we're trying to get to water, but we still have to go through moles. You always, always, always have to go through moles. And I don't know why I just wrote water on that step. So 1 mole of HNO3 to 62.115 grams of HNO3. For every 2 moles of HNO3, you have 2 moles of water. Type that in. You should end up with 0.0942 moles of H2O water. Good. So now you know how to go from grams of a compound to moles of a compound. Moles of one compound then converted to moles of another compound. Woo! Are you tired yet? Let's go just a little bit further. So now we have 3.24 grams of nitric acid and excess calcium hydroxide. Notice for this example, I decided to take it one step further, and now instead of looking for moles of product, we're looking for grams of product. So let's do A first. .24 grams of nitric acid. And if you want to pause it right now, I really do suggest pause it, give this a try. Because giving it a try will help you get it, I think, more. Because then you can double check yourself and see if you're doing it correctly. 3.24 grams of HNO3. We need to convert from grams to moles. So in order to do that, we use the molecular weight of HNO3. And then we look at our balanced chemical equation, where 2 moles of HNO3 for every 1 mole of calcium nitrate. Then we need 1 mole of calcium nitrate. We need our molecular formula. So calcium nitrate is 164.086 grams of calcium nitrate. So notice what we have done here. We have used molecular weights twice. Those are both our molecular weights. One was to convert from moles, from grams of nitric acid to moles of nitric acid. The other one was convert from moles of calcium nitrate to grams of calcium nitrate. But they're both using the molecular weight. Then to get from moles of one substance to moles of the other, we used our balanced equation. So let's put this in our calculator and see what we end up with. 3.24 times 164.086 divided by 62.115 divided by 2. Gives us a total of 4.28 grams of calcium nitrate. Good. Let's do B now. We're starting out the same way once again, but at the very end, we're going to have a different molecular weight. So we have 3.24 grams of nitric acid times 1 mole of nitric acid to 62.115 grams of HNO3. Now we're trying to get from moles of nitric acid to moles of water. So we've got 2 moles of water on top from our balanced chemical equation. Now we have 1 mole of H2O is equivalent to 18.015 If we multiply all of that together, times 2 times 18.015 divided by 62.115 divided by 2, we should end up with 0.940 grams of H2O. If we wanted to make that a little more tricky, we then, turn it into liquid using density as a conversion factor to take you from grams to volume. But we'll stop there. So once again, you went from grams of one substance to moles of the same substance using the molecular weight. You went from moles of one substance to moles of another substance using the balanced chemical equation. Then you went from moles of one substance to moles of that same substance to grams of that same substance, using the molecular weight of that substance. All right, give this one a try. This is very similar once again, except for now we're looking at molecules instead of just simply grams. So instead of starting out that last part with grams, we're starting it out with molecules. So that means we have to use Avogadro's number to convert. So for A, we have 2.15 times 10 to the 22nd molecules of HNO3. And we need to get that all the way to grams of calcium nitrate. So we convert from molecules to moles by Avogadro's number. So there are 6.022 times 10 to the 23rd molecules of HNO3 and 81 mole of HNO3. We need to get from moles of HNO3, to moles of calcium nitrate. So there are 2 moles of nitric acid for every 1 mole of calcium nitrate. Then at the end, we're trying to get to grams. I could have asked you at this point molecules, I could have asked you moles, but you have to look at the question and see what it's asking you. So in this case, it's asking us about grams. So 1 mole of calcium nitrate. We look up our molecular weight of calcium nitrate, which we calculated earlier. Sorry, my handwriting is getting worse and worse as I'm trying to write smaller. Okay, so let's look and see what we did here. And notice all of our stuff is canceling it. I haven't been canceling it out, but I hope you've been able to follow that. Molecules of HNO3 cancels with molecules of HNO3. Moles of HNO3 cancels with moles of HNO3. Moles of calcium nitrate cancels with moles of calcium nitrate. And we end up with grams of calcium nitrate, which is what we wanted. So we have our molecular weight here. We have our chemical reaction that's been balanced here. Why did you guys let me write molecular weight? That's totally not what I meant. Yeah, no, there's no one in the room with me. Oh, who knows? Okay, so we've got Avogadro's number is what we've got going on right there. And then our molecular weight is right here. So we had to use all 3 things that we know how to utilize in order to solve this problem. Avogadro's number, the chemical reaction, and molecular weight. The way to get good at this is literally practice, practice, practice. I can't emphasize that enough. Practice, practice, practice. So let's do our math and figure out if you have 2.15 molecules times 10 to the 22nd molecules of nitric acid, how many grams are being produced. So 2.15 times 10 to the 22nd times 164.086 divided by 6.022 times 10 to the 23rd divided by 2. We end up with 2.93 times 10, nope, not times 10, times 10 to the 0. And our units on that are grams of calcium nitrate. Let's do B. 2.15 times 10 to the 22nd molecules of HNO3. We want to use Avogadro's number to convert to moles. Then we need to use our balanced chemical equation to convert from moles of nitric acid to, in this case, we're looking for grams of water. So we've got for every 2 moles of water. Then we can use the molecular weight to convert from moles of water to grams of water. So we have 18.015 grams of H2O. Type that into our calculator. 2.15 times 10 to the 22nd times 18.015. Notice our 2 here and our 2 here cancel, so you don't have to type that into your calculator. Divided by 6.022 times 10 to the 23rd equals 0.643 grams of water. So notice this is a perfect example. You can't just use grams to solve a problem because you start out with the same number of molecules of nitric acid. You would think you would produce more of water, but notice you produce 2.93 grams of calcium nitrate and 0.643 grams of water. So it looks like you produce less of water, but in actuality you still produce more molecules. You produced a lower mass of water, but you produce more molecules. So we've really covered a lot in this lecture, but mainly you can boil it all down to this. You can use the chemical equation to convert between grams, moles, or molecules of a substance to grams, moles, and molecules of another substance. But you have to use all 3 conversion factors: your balanced chemical equation, Avogadro's number, and the molecular weight. If you know how to use those 3 things to convert between moles to grams or moles to molecules, or vice versa, then you understand this lesson. Once again, this lesson is best performed if you're able to practice, practice, practice. And remember that in the end, moles are the link that ties everything together. You can't go from grams to molecules without first going through moles.